So in this particular video, what we're going to do is we're going to go over the trigonometric functions unit test, identities unit test, and we're going to be working through problems together. Hopefully as I do the problems, you'll have some understanding of what it's asking you to do. We have a cosine graph here. It looks like it says 1.5 cosine. It's positive. So our graph is going to look like this. It's going to go down and then back up right there. Okay, and so in that cosine graph, you know you're going to have a midline. So I'm going to go ahead and draw on a midline. Let's just say that's a midline. Okay, so it looks like our midline is at 4.3. All right, but it says what is the second time after the summer solstice that the solar irradiance is 5.2. So it's looking for the second time. So the first time it would be at 5.2 would be, say, somewhere around right here. But the second time it's going to go back down and back up. So it's actually looking for this answer if, let's say, that right there is at a 5.2. Because our amplitude, all right, is 1.5. So if we go up 1.5 from that, that means our highest point, if we add 1.5, would be 5.8. So our highest point is going to be all the way up here at 5.8. And then if you took 1.5 away from that, then you'd have your lowest point down here. And if you take away 1.5, you're going to get 2.8. So that'd be your minimum. And so it says round your final answer to the nearest whole day. So once we get our final answer, we just round to the nearest whole day. So we're going to go ahead and start off. We're going to, instead of I of t, we're going to plug in a 5.2. So just go ahead and put 5.2 equals 1.5 times the cosine of 2 pi over 365 times t plus 4.3. So there we go. What we're going to do now is we're going to go ahead and start solving for t. Excuse me. So our first step that we would do is we would take away 4.3 from this side, and we would take 4.3 away from this side. All right. So when you do that, you're going to be left with 0.9. 9/10 equals 1.5 cosine 2 pi over 365 times t. Then you're going to divide both sides by 1.5. All right, so just do 0.9 divided by 1.5 gives you 0.6 or 3/5. So I'm going to say we have the cosine of 2 pi over 365 times t equals 3/5, because all this equals 0.6, which is 6/10, which reduces to 3/5. All right, so that's kind of the very first part of it. All right, so once we get here, what we're going to do is we are going to take the inverse of cosine on both sides. So we're going to do the inverse of cosine on this side, and we're going to do the inverse of cosine on this side. It's cosine of -1. It's kind of hard to see. These cancel out. So here's what you're left with. You're left with 2 pi over 365 times t equals the inverse of cosine. Now we need to be in radians right now. So let's take a look at what that would be if we were going to go ahead and do it in radians. I'm going to get my graphing calculator out real quick. Take a look at that. You can do this in Desmos as well. So I'll show you in Desmos how to do it. Make it a little bit bigger. There we go. Okay. So I'm going to go to modes, make sure I'm in radians right here. Hit second cosine, do 3 divided by 5. In radians, it's approximately equal to 0.927. Okay, so that right there, that's what I would use if I wanted to use the first time. But there's also an identity, basically something that's equal, and that's 2 pi minus something you need to know right here. If you want to look for the second one, you can say cosine of theta will always equal the cosine of 2 pi minus theta. All right. So, for example, since we're going to be going an additional length, like we're going to find the second one, I'm going to use 2 pi minus theta to help me find that. So let's go ahead and do 2 pi. L2. 2 pi minus theta. And I'm going to use this number right here instead of the first number. So we're gonna solve it both ways so you can see what I'm talking about. So see that 0.927? We're going to go ahead and use that one. So I'm going to right over here. I'm going to put 2 pi over 365 times t equals that approximate value of 0.927. But I also found another decimal, which is that, let's see if we have it there. Don't see it. My apologies. Oh, it's right here. There we go. 5.36. We'll put 5.35. 5.356. Let's go and use that one. 2 pi over 365 times t equals 5.356. So we're going to solve for t using both of these, and hopefully by the time this is all said and done, you will understand why I did that. So we're going to multiply this side by 365 over 2 pi, and I'm going to multiply this side by 365 over 2 pi, and that's going to give me my first answer. Okay, so this right here will give me my first answer. But once again, I got to multiply by 365 over 2 pi on both sides of this one as well. Don't have enough room to put it on both sides, but hopefully you'll understand what I'm doing. So we're going to find this answer as well. So we're going to get two different answers. So right here, all I'm going to do is I'm going to take the first one right here, and I'm going to multiply it. I'm going to go alpha y equals enter. I'm going to type in 365 over 2 pi. Press enter, and I get 53.86, which basically means 54 days. Then I'm going to go up here and grab this one right here. And once again, I'm going to multiply it by 365 over 2 pi. And I'll close the parentheses this time. 311. So that equals 311 days. So the first time that it hits the 5.2 is 54 days, and the second time it hits it is 311 days. And what I told you, that's going to be an important thing to know. This is the first time. This is the second time. If it asks you for the first time, you don't have to do this. But if it asks you for the second time, I need you to understand the cosine of theta will always equal the cosine of 2 pi minus theta. So let me prove that to you here, okay? So if I said the inverse of cosine of 3/5, which we eventually got, was this. Well, look what happens when I say, what is the cosine of 2 pi? Cosine of this. There's the cosine of that, which equals 0.6. Look what happens when I say, what is the cosine of 2 pi minus this? Didn't mean to do that. Didn't mean to So here's what I want you to see. This right here is theta in radians. That's theta in radians. Well, the cosine of 2 pi minus theta gets us to the same answer right here. All right, so when we go to Desmos and we type everything in, here's our original equation. Here is y equals 5.2. And you'll see the very first day that it hits it is at 54 days, and the second day is 311 days. Now the midline, let me make sure you guys understand, the midline is y equals 4.3. There's the midline. So here's our graph. Now if you're wondering what are the settings on my graph, the settings, basically I set the settings at 0 to 365 so I could see it. And then here I just basically set the settings from 0 to 6. And that allows me to be able to see the graph and see, hey, there's the first time it hits the 5.2, there's the second time that it hits the 5.2. So that's why I feel pretty confident. I'm going to go ahead and type in 311. Make sure I've rounded it correctly. That would stink if I didn't. Okay, I did. 311. Okay. So that's what I would want you to do when you're working. And the reason why I did the whole 2 pi minus theta is because of this. It says what is the, not the first time, but the second time. So I had to do that little extra work. All right, here we go. We got 4 different answer choices. It says the following are all angle measures in radians rounded to the nearest hundredth whose tangent is negative 21. What is the principal value of the inverse of tangent of 21? And well, it's in radians. So if I were to go to Desmos, you can do this in Desmos as well. All you got to do is go to functions, go to the inverse of tangent, type in negative 21, and as long as you're in radians, it's going to give you the answer, which is negative 1.523. In degrees, that would be negative 87.3 degrees. In radians, it's negative 1.53 radians. So negative 1.52. My bad. Wrong one. Okay, yeah, negative 1.52 is correct. All right, so that's pretty easy. Just find the inverse as long as it's in radians. Keep it in radians. Okay. Now what we're going to do is we're going to use the angle addition or subtraction formula to find the exact answer for the cosine of 345 degrees. So when you guys are doing these problems, the main thing you want to look for is you need to look for patterns of the 45, 45, 90, and look for 30, 60, 90 triangles. Okay? So I'm going to write these down. 45, 45, 90 deals with x, x, x radical 2. So put a 1, and a radical 2. There's your little chart. You need to have this chart. The 30, 60, 90, we're dealing with x, x radical 3, and 2x. I'll go ahead and draw the triangles out, even though I really don't feel like it because I've done it so many times. And I really doubt that anybody's going to watch this video, but sometimes, you know what, you just like Atticus Finch, you just do it because it's the right thing to do. So there's the 45, 45, 90. There's the 30, 60, 90. And the 45, 45, 90, also known as the isosceles right triangle. This is a 1, and a 1, and a radical 2. And I'll put the 45 degrees there. There's the 45, there's the 90, there's the 45. Here's 60 degrees. It's a horrible 60-degree symbol. I've been doing videos all day long for you guys. You know what? During all of this time, I've probably done way more math than all of you. All right, and then we have a 1, a radical 3, and a 2. So there's 30, 60, 90. Degrees, degrees, degrees. Degrees, degrees, degrees. All right. So how in the world are we going to do cosine at 345 degrees? Well, there's a lot of ways to do this. But what I'm going to do is I'm going to break this down into the cosine of 225 degrees plus 120 degrees. Because if you take 225 and 120, it adds up to 345. Is this the only way to do it? No, but it's the way that I'm going to do it. So we're going to take a look at the cosine addition formula. Cosine angle addition. Let's look at cosine addition. Here we go. Cosine, cosine minus sine, sine. Cosine, cosine minus sine, sine. So we're going to put the cosine of 225 times the cosine of 120 minus the sine of 225 times the sine of 120. And that's what I'm going to use to solve this. All right, so I'll go back right here. Cosine times cosine, basically that's the two different angles. That's theta, that's phi. Basically, I call them x and y, x and y. So we have cosine, cosine minus sine, sine. Use the correct formula. And now all I'm going to show you how to do is find the cosine of 225 and the cosine of 120. And this is all the concept of the unit circle. So what I'm going to do is I'm going to draw a couple of unit circles. All right. Got one here. Got one here. All right. So there's our unit circle. It's so much faster when I can just do the math instead of teaching the math. But you know what? I'll have to hopefully understand the concept of the unit circle. All right. So I'm going to draw the unit circle if it'll let me. All right, so here are my unit circles. The first thing we're going to do is I'm going to show you guys what a 225 degree angle looks like. So 225 degrees is going to start right here, and then you are going to rotate it. All right, you got 90, you got 180, 180 plus 45. That puts you at 225 degrees, puts you right about there. So this is the angle. This is the triangle that you would build from that 225 degrees. The 225 degrees starts here, and then it arcs all the way across over here. So that right there is your 225 degrees, which puts you clearly in quadrant number 3. So in quadrant 3, you're going to have a negative x value and a negative y value in quadrant number 3. So there's your 225 degree angle. Now 120 is a little bit different. Right here, you start here. If you arc it from here to here, that's 90 degrees. All right, we're going to add a little bit more to that. We're going to add another 30 degrees, and that's going to put you right here. So here's the triangle that you would use for the 120 degree angle. All right, so you can clearly see that this is 60 degrees. This is 30 degrees. This angle right in here is 120 degrees. So what is this angle right in here going to be? That's going to be 45. So we have a 45, 45, 90 triangle. Okay? And then we have a 30, 60, 90 triangle. So what I'm going to be doing right now is I'm going to be finding what's called the sine of 225. And I'm going to be finding the cosine of 225. Like that. On this one, I'm going to be finding the sine of 120, and I'm also going to find the cosine of 120. All right? Now, on this one, I'm going to use right here, since we're going negative, we're going to call that -1 and -1 for our x values. We're going to call this radical 2. And over here, we're going to say, as it goes from here to here, we're going to call that -1. We're going to call this radical 3. We're going to call that a 2. So we're going from this perspective right here, from the 60 degree perspective and from the 45 degree perspective. So from this perspective, what we need to do is we need to label our opposite side, our hypotenuse, and our adjacent side. And over here, you're going to label that guy your opposite side, this guy your adjacent side, and this side your hypotenuse. Now, I already have all these memorized, but I'm going to show you guys how to find the exact numbers that go with it. By the way, if you guys have a calculator, you can kind of remember. Once you find these, you will know them, and they don't change. So remember, the sine, when you're dealing with SOHCAHTOA, someone's going to write SOHCAHTOA. Sine is the opposite over the hypotenuse, okay? Well, if I take the opposite over the hypotenuse, that's going to put me at -1 over radical 2, which simplifies to negative radical 2 over 2. Okay? The cosine is the same thing. It's negative 1 over radical 2, which once again simplifies to negative radical 2 over 2. And we've rationalized the denominator enough that I'm not going to go over that process in this particular case because you should have already watched the video that goes over it. All right, the sine of 120. So what's the sine? The opposite over the hypotenuse. Well, that's easy. That's just radical 3 over 2 because that's the opposite over the hypotenuse. What's the cosine? Negative 1 over 2. So the cosine is going to be negative 1 over 2. And these are the numbers that I'm going to use when I'm kind of filling in our formula. Okay. Now, we're going to go over some numbers real quick. Okay. Except what we're going to do is I'm going to put this in degrees. We're going to go mode. We're going to go to degrees. But being that you guys probably don't have a graphing calculator, I'll go ahead and do it in Desmos. So I'm going to go over here, make sure we're in degrees, and I am going to type in what is the sine of 225? And what's the cosine of 225? And what's the sine of 120? And what's the cosine of 120? There we go. Now, what I want you guys to understand is that radical 2 divided by 2 is that 0.707 every single time. And something you also need to know, saves you some time and energy, if you can memorize that radical 3 over 2 is that 0.86, is 0.866 something. Oh, try it again. I'll get there eventually. 2. All right, if you know radical 3 is 0.866 over 2 is 0.86, then you know that automatically, sine of 120. If you just type it in, you know that's radical 3 over 2. You know this is negative radical 2 over 2. You know that's negative radical 2 over 2. It makes it so much faster. It's unbelievable. Just spend some time and memorize these. Like radical 3 is 1.73. Sometimes you'll need radical 3, which is 1.73. Just if you memorize them, your life's goes a lot faster. So let's go back to our work. Okay. 22 minutes already. We've only done 2 problems. Great. Googly moogly. All right, so the cosine of 225 was negative radical 2 over 2. So I'm going to put negative radical 2 over 2. And the cosine of 120 was negative 1/2. All right, so cosine 120, negative 1/2. So negative times negative is positive. That becomes radical 2 over 4. And then we're going to put minus, parentheses, parentheses. Now, the sine of 225 is another negative radical 2 over 2. And then the sine of 120 is positive radical 3 over 2. We've got a negative and a negative, which makes it a positive radical 6 over 4. Now, what's that going to leave us with? That's going to leave us with radical 2 plus radical 6 all over 4, which is going to be answer choice C. What I want you guys to do is I want you guys to kind of start memorizing what these ratios are, and then you can just plug them into the formula, and it's a heck of a lot faster. Okay? All right. So right now, what we're going to do is we're going to select one or more expressions that deal with this problem. This is going to go a lot faster than the last one because I ain't going to do a big whole unit circle over a whole bunch of angles. We're just going to solve it. So let's get your pencils out and let's get to solving. I apologize if I sound a little frustrated. I've been working on 5 videos. Been working on 5 hours of videos so far. Actually getting close to 6 hours of video for all of my math classes. And I am starting to wear out. So here we go. 6 hours. Hope you guys are watching this in mind. So the first thing we're going to do is we're going to take away a 14 from this side, and we're going to take away a 14 from this side. So now you're left with 30 times the cosine of 30 equals negative 30. Somebody likes 30s. I don't know. Maybe this person was 30 years old when they made it. Then we're going to divide both sides by 30, and we have the cosine of 30x equals negative 1. In remembrance of Howard Cosell, since we're doing cosine. If you don't know who Howard Cosell is, you should look up Howard Cosell and Muhammad Ali. Some great videos there. Alright, so now, cosine of 30x equals negative 1. This is where we need to apply what's called the inverse of cosine on this side. And then I'm going to apply the inverse of cosine of negative 1. Now, it's going to be in radians, so I got to do this in radians. So here we go. Let me look real quick. Let me go over here. Delete all this stuff. Functions. Inverse cosine. Negative 1. Oh, 180 degrees. I bet that's pi. So here we go. Let's go over here. Change it to radians. Hey, look, it's that 3.14. So the inverse of cosine at a negative 1 is simply at what value? The inverse of cosine negative 1 is at pi. So we're going to write that down. So 30x equals pi. Write that down. It's important. Remember when I told you I wasn't going to use the unit circle? Well, I lied. We're going to have to do one more unit circle. All right. So it won't take long. I want you to understand that in the unit circle, there's only one time where the cosine is equal to negative 1, and that's the only scenario, which is at 180 degrees, also known as pi. All right. So the only time where we have a negative 1 and a 0 in the unit circle is at pi. So basically, what we could do is we could add 360 degrees times n, and that would get us to that every single time. But we're going to, because we're in radians, we've got to change that 360 to plus 2 pi times n. But what we have to do is we have to divide everything by a 30. Okay? And so when we do that, we get x equals pi over 30 plus, and 2 goes into 30 15 times, so I'm going to put pi over 15 times n, and that's going to be the answer that I'm gonna search for. Okay, so let me go look over here and see if I can find that answer. Pi over 30 times, oh, there it is, answer choice D. It's the only one. There's only going to be one answer this time because there's only one place on the unit circle where cosine is negative 1. Alright, this one's going to be a heck of a lot easier. It's very, very simple. All we got to do is find all the answers that apply. Once again, I am going to draw the unit circle to try to help explain the whole process. So we have a unit circle right here. So I'm going to draw the two scenarios where the sign is negative. Sign is negative in the third quadrant and the fourth quadrant. So in the third quadrant, sign will be negative because the y values are negative. And in the fourth quadrant, sign will also be negative because the y values are negative. So we got negative 7 over 10. All right, so we got negative 7 over 10, which basically means that's the y value, that's the r value. So you're going to have a triangle that looks something like this. It's going to be here, and it's also going to be right here. So I'm just going to draw the unit circle as best as I can. So what does this mean? That means this right here, I'm going to call that negative 7. I'm going to call this radius 10. I'm going to call this negative 7. That's supposed to be a right angle, and that's a 10. So we're going to be looking for two angles. Okay. The first angle we're going to look for is going to be a negative degree. So all we're going to do right here is use the inverse of sine. So do the inverse of sine of that negative 0.7, which is negative 7/10, and let's see what we get here. First of all, we got to change it to degrees because now we're in degrees. So hit the inverse of sine, which is negative 0.7, which is negative 7/10. So we get negative 44.4 degrees. All right. But what you're going to do is you also have to go a little bit further. So if I do 180, all right, and I'm just going to add, or actually just subtract, let's put minus 44.427. we get 135.57. And that's going to be the other one. So the first one was negative 44.43 degrees. That's this angle right in here. But the second one is a negative from here all the way across right in there. And that's going to be negative 135. My bad. 0.57. And then we're just going to add n times 360. All right, so like how are you supposed to know how to do this? Well, you got to know where sine's negative. Sine's negative in the third and the fourth quadrant. All I did was I took the first angle, which was negative 44.43 degrees. These triangles are in the wrong. It's not an accurate picture of what's actually happening. Okay, but you guys get the picture. These right here are going to be supplementary as far as when you're solving them. All right, so I'm going to put negative 44.43 and negative 135.57. So negative 44.43, and then scroll down here to negative 135.57. That will give us all the answers that are the inverse of, or sorry, the sine of x equals that. All right, so this one, it says, how long does it take Lena to compress the accordion completely and then stretch it back out to a length of 50? All right, so it's going to be compressing and then stretching. So here we have a cosine. Looks like we have a cosine graph again. All right, so let's kind of draw a little picture of this. So our cosine graph, it's going to start right here. It's going to go down. It's going to go back up. It's not a very good picture, but you get the idea. So just draw a little graph with me, okay? Looks like our amplitude is 25. We have a midline of 65. So all I'm going to do is I'm going to draw the midline right here. All right, and our midline is going to be at 50. Sorry, not 50, 65. So there's our 65. That's our midline. All right, so our amplitude is 25. So if I go 25 up, it's going to put our maximum at 90. Okay, and then right down here, our minimum, if we take away 25. All right, so if we take away 25 right here, it's going to put us at 40, because 40 plus 25 gets us back to 65. All right, so now we kind of have a picture to go with it. All right, so it says Lena is playing her accordion by compressing and stretching. The accordion length, all right, is in centimeters. T seconds after it's completely stretched out is modeled by this equation. All right, so it looks like when it's completely stretched out, it's at 90, and then it gets to all the way compressed to 40, and then gets stretched back out to 90. And we're trying to figure out how long does it take Lena to compress the accordion completely and then stretch it. So dadgummit, looks like it's going to be asking us for the second one again. So let's just pretend like this is about a 50. So right now it's stretched out completely. It's compressed. It's compressing right here. That's at a 50, and then it completely compresses, right? Completely compresses, and then it stretches back out again. And so we're looking for the second one. So once again, we're going to have to use that identity, the cosine of theta equals 2 pi minus theta. So we're going to be using that once again. All right, this won't take too long. We're just going to go ahead and plug things in. So we want to get to 50, so we'll put 50 equals. And we're going to go over here and put 25 cosine. 25 cosine. And then it looks like we have what? Pi t. All right. Pi times t. And then it's plus 65. Plus 65. All right. Yep, right there. Okay. So first step, we're going to take away 65 on both sides. Okay, so we get negative 15 equals 25 times the cosine of pi times t. And we're going to divide both sides by 25. Okay. And when you take negative 15 divided by 25, that reduces to a fraction of negative 3/5. So it looks like once again, we're at a negative 3/5 equals the cosine of pi times t. Now, we're in radians right now because it says t is here. This is in radians, so we got to make sure we're in radians. So what we have to do is we got to do the inverse of cosine on both sides. So what I'm going to do is I'm going to do the inverse of cosine here and then do the inverse of cosine here, so those cancel out. So we're going to figure out what the inverse of cosine is. I'm going to type it in right now. But this time I got to make sure I'm in radians this time. All right, here we go. Functions. Inverse cosine. Negative 3/5. Negative 3/5. Negative 3/5 is 2.21. So I'm going to put 2.21 equals pi times t. But remember, we have to do the second time. So if I want to do the first time, I just divide both sides by pi and I'm done. But the second time, I got to use 2 pi minus theta. So here's what I'm going to do right now. Check this out. I am going to go to Desmos. I am going to type in 2 pi minus 2.21429743559. And I get 4.0688. Okay? So, 4.0, we'll put 4.07. So I'll just do that, 4.07. So if I do 2 pi minus the 2.21, I get that 4.07. So I'm going to set that equal to pi times t. And then I'm going to divide both sides by pi. And this should give us the first time. So we're going to go over here. Okay, we're going to take that 2.21429743559, and we're going to divide all that by pi, and we're going to get 0.70. And then we're going to go up here and take the 4.06888787159. We're going to divide that by pi, and we're going to get 1.29 or 1.3. So basically 0.7 or 1.3. 0.7 or 1.3. Now what we're going to do is we're going to type all this into Desmos and see if we did everything correctly. I think it's going to be 1.3. Let's see if I made a mistake. If I did, well, we'll find out. Because we're going to type the sucker into Desmos and check our work. Let's see here. I believe it was, what, 25 cosine? 25 cosine. And I'll put parentheses. We had a pi, then I'll put x instead of t. That's a lot of. And then, I know it's kind of hard to see right now. And then it was plus 65. Okay. What we're gonna do is we are going to adjust the graph settings. All right. And being that we're doing really small numbers, we're going to start with 0, and we're just going to go to 2. Go to 0 to 2. But our y values, what we need to do is we need to go from, I think it was 40 to was our maximum? 90? 40 to 90? Then we should be able to see our graph. There we go. There's our graph. Cool. Now I can kind of see it a little bit better. And then what we're going to do is we're going to put y equals 50. And then we're also going to put y equals 65, which was the midline. Okay. All right, so here we go. So it looks like the first time was 0.7. We got it right. 0.71. Okay. And the second time was 1.3. We got it right. Or 1.30. So just by doing the math. Sweet. So let's see what the question says. Nearest tenth of a second. Nearest tenth of a second. Well, we're going to put 1.3 for our answer. Cross our fingers. 1.3. Woohoo! All right, you know what? I have done almost all of these problems. These are going to be the same type of problem. I think I covered the most difficult ones. We have, what, 3 to go? Well, let's do one more, I guess. Let's do one more. See if this is not that bad. We're going to be in degrees, so this won't take that long. So, here we go. But it is 41 minutes, so you probably have had to take a few bathroom breaks, especially if you've had enough coffee, as much coffee as I have. All right, equals 3. Oh, this is going to be easier because it looks like sine's going to be in the first quadrant and the second quadrant. Sweet. So we're just going to add 1 to both sides. And we get 5 times the sine of 3x equals 4. We're going to divide both sides by 5. And we get the sine of 3x equals 4/5. Well, that's clearly in quadrant 1. It's going to be really, really, really easy. All I'm going to do is do the inverse of sine. Make sure it's in degree mode this time. So I'm going to hit second sine. Or, sorry, inverse of sine. And what did I say? It was 4/5? Add 1 to the side. Yeah, 4/5. 4 divided by 5. So 53 degrees. So we're at 53 degrees, and then if I do the supplement, 180 minus the 53.13, so we're at 126.87. All right, so that's where we need to be. So in the unit circle, this is in quadrant 1 and quadrant 2. So we're going to start with the 53.13. And the 126.87. Now, this is all equal. This is all equal to 3x. So, here's what you're going to have to do. If you wanted to get back to these, you'd have to add 360 times any integer, and that would get you to those 2 spots. Okay? So remember, this is the quadrant 1 answer. This is the quadrant 2 answer. So if you're like, what are you talking about quadrants? This is quadrant 1. This is quadrant 2. So this angle would be 53. This other angle would be the 126. We're in quadrant 1 and quadrant 2, and we're dealing with positive sign. Okay. All right. And then what you're going to have to do, if all of this is equal to 3x, and all of this is equal to 3x, and I got to divide everything by a 3. So I got to divide this by a 3, I got to divide this by a 3, this by a 3, this by a 3. So what we're going to have to do is we're going to have to take this 53.13, we have to divide it by 3. That's 17.71. Then you're going to have to take that 126.87 and you're going to have to divide that by 3, which is 42.9. Okay? Just remember, 360 divided by 3 is going to be 120. So our final answers are going to be this. It's going to be 17.71 plus 120 times n and 42.29 plus 120 times n. Those are the 2 answers that I'm going to be looking for in this particular problem. All right? So 17.71 plus 120 times n, right? There's that one. And then, 42.29 plus 120 times. Those are my 2 answers. Because both of these are going to be, this is the one that's going to be in the first quadrant, that's going to be the one that's in the second quadrant. Okay? This one shouldn't be that hard. It says, what are all the following angle measures whose tangent is 2.6? Arctangent is 2.6. You're just doing, it looks like it's in degrees, so all you got to do is literally do the inverse of tangent and make sure you're in degrees. Okay, so here we are. We're still in degrees. Arctangent is just the inverse of tangent. So we're just going to go inverse of tangent and type in 2.6. And it looks like it says 68.96 degrees. So we're looking for the answer that basically is 69 degrees. Okay. And then if you wanted to find the sine of 11 over 12 pi, the first thing you would do is you would multiply 11 pi over 12 by 180 over pi, just to see what you are in degrees. It's a lot easier to work in degrees than it is in radians. So if I did, what's 11 divided by 12 times 180, because the pi's can't, you're at 165. All right. So if you are at 165 degrees, probably the easiest thing to break it down to would be 120 and 45 degrees. And since we're using the angle addition, I'm going to use the sine of 120 plus 45 degrees. And I'm not going to go over the whole 40, 30, 60, 90, and 45, 45, 90. We're just going to work this out like I would work it out. So we're going to, first of all, we're going to look at our formula. Here's the formula: sine, cosine, plus cosine, sine. So we have sine, cosine, plus cosine, sine. All right, so we're going to go over here. We're going to put sine of 120 times the cosine of 45. You know what? I'm going to do it underneath it. Gives more room. We're going to call this x. We're going to call that y. We're going to say the sine of 120 times the cosine of 45 plus the sine of 45 times the cosine of 120. So we're going to use that formula: sine of x, cosine of y, plus the cosine of x and the sine of y. All right, here we go. So what is the sine of 120? So I'm just going to, all right, fine, I'll just type it. What's the sine of 120? Radical 3 over 2. Sweet. Sine of 120 is radical 3 over 2. Cosine of 45 is radical 2 over 2. What's the sine of 45? Radical 2 over 2. What's the cosine of 120? Well, that's going to be negative 1/2, but I'll go and type it in. Cosine 120, negative 1/2. There you go. All right, so now we just multiply together. We got radical 2 times radical 3, which is radical 6 over 4, plus we've got a negative radical 2 over 4. So basically, it's just radical 6 minus radical 2 all over 4. So like I said, if you know all of your decimals, it makes it a lot easier when you're trying to find your simplified answers without having to go through the whole process of the unit circle. But I'm going to choose answer choice D and call it a day. There you go. You'll have a wonderful day. That's 9 questions and under 50 minutes. Hope you didn't have to go to the bathroom too many times during this video. Have a wonderful day and an even better